let's talk about one of the most basic symbols in all of math, the minus sign. It feels so simple, right? But what if I told you its real meaning is way bigger and, honestly, way cooler than just taking something away? We're going to get into it.
You've been there, right? Staring at a math problem, and you hit that rule, minus a minus makes a plus. You just kind of have to accept it and move on. But it feels weird, doesn't it? It goes against your gut. Well, you're definitely not alone in thinking that.
And yeah, our everyday language doesn't help. You look up minus in the dictionary, and it's all about making something smaller, having less of it. So how on earth does minusing a minus end up giving you more? That's the clash right there, between what we feel and what the math says.
And here it is, the rule in all its glory. 2 minus negative 2 equals 4. We all learned it, we use it, but the why of it all usually gets skipped over. Today, we're not skipping it. We're going to find that why.
So, here's the big secret. The minus sign's job isn't just to take away. That's only a small part of its story. To really get it, we need to zoom out and look at a much more elegant idea, the concept of an inverse. And trust me, this one change in perspective makes everything click.
But okay, before we can talk about an inverse, we have to know what we're getting back to. In the world of adding and subtracting, our home base is the number 0. It's called the additive identity. You add 0 to anything and nothing happens. It stays the same. That's actually what makes it so important.
And this is where the inverse makes its entrance. You see, for every single number, there's a perfect opposite, a counterpart that balances it out completely. We call that its additive inverse. So for a number like 5, its additive inverse is negative 5. Put them together and you get right back to home base, 0.
Let's make this way more simple. Forget numbers for a second. Imagine any positive 1 plus 1 is just a blue ball. Got it? And any negative 1 minus 1 is a red ball. So we've got our two kinds of balls, blue for positive, red for negative.
So what happens when they meet? Well, they're inverses of each other. So if you take one blue ball and one red ball and put them together, poof, they just annihilate each other. They vanish, leaving you with nothing, 0.
Okay, so let's look at the minus sign again with this new idea. When you see a number like, say, negative 2, try not to just think negative 2. Think of it as an instruction, a command. Find the additive inverse of 2. See that? The minus sign is an action, not just a description.
And this totally cracks our original puzzle. Just read the expression out loud as an instruction. Negative 2 is really saying, take the inverse of negative 2. Well, what's the inverse of negative 2? It's the number that you add to it to get back to 0. And that, of course, is positive 2. The inverse of an inverse just brings you right back to where you started.
And this is where it gets really cool. This whole inverse idea isn't just for adding. It's like a fundamental pattern woven into the fabric of mathematics. You see it pop up all over the place, and it often uses the exact same notation.
Just look at this table of exponents. Let's follow the pattern down the rows. Each step, we're just dividing by 4. 16 becomes 4, 4 becomes 1. So if we follow that same pattern, 1 divided by 4 becomes 1/4. But now, look at the exponents. The pattern on that side forces 4 to the power of negative 1 to be the same as 1/4. Whoa! That negative sign has nothing to do with negative numbers here. So that little negative 1 up there in the superscript, it's another inverse instruction. In the world of multiplication, it means take the multiplicative inverse, which is just a fancy way of saying flip it, or take the reciprocal. It's the number you multiply the original by to get back to the multiplicative home base, which is 1. It's the same idea, just in a different context.
And the pattern just keeps going. Look at functions. If you have a function that does a bunch of stuff to a number, its inverse function, and look, there's that same negative 1 superscript again, it literally undoes all of that stuff in reverse order. It's the undo button for a function.
And this concept is so powerful, it just keeps scaling up. When you get into more advanced math, you'll see the same inverse notation on things like matrices. Now, you don't need to know what a matrix is. Just appreciate that even with these super complex objects, that little negative 1 symbol still means the exact same thing. Find the thing that undoes the original.
And you know, this isn't just some weird math thing. We live this idea every day. The world is built on these pairs of opposites. For every action, there's an undoing. Going east is the inverse of going west. Screwing a lid on
is the inverse of screwing it off. It's the same deep, logical pattern. So what's the big takeaway from all of this? When you come across a rule in math that just feels weird or totally random, our first instinct is just to cram it into our brains for the test and move on. But that's when we miss out on all the good stuff.
This right here is the most important part. Don't think of math as just a long list of boring rules. Think of it as a story. Every formula, every idea is like a character or a plot twist in this huge interconnected narrative. Real understanding doesn't come from memorizing the lines. It comes from following the plot.
So the next time you're stuck, don't beat yourself up. Get curious. Ask yourself the most important question you can. What's the story here? What bigger, cooler idea is this little rule a part of? We just saw that the story of minus a minus is a plus was really the awesome story of the inverse.
So that kind of leaves us with one final thought. What about all those other weird math rules? Like why when you divide by a fraction, you flip it and multiply? Could it be that those aren't just random rules either? Maybe they're just more beautiful, logical stories that you just haven't heard yet.